Venn diagrams and set operations. Here we go. These warm-ups, just good practice. We want to use set notation for the set of Mr. Jones, Mr. Godkin, Mrs. Essery, Mr. Fluga, Mr. Olive. Well, if you attend Dallas High School, you would know that we're going to call this the set S for science teachers. In set notation, we want to make sure we have our brackets X such that X is a science teacher at Dallas High School. List all the subsets for the set below. There are 3 elements. Because we're talking about subsets and not proper subsets, there should be a total of 2 to the 3rd, so 8. Here goes nothing. The first subset is going to be the empty set. Then we'll list each color, and I'll abbreviate individually. And then we have to do the pairings. Keep in mind, red, yellow, yellow, red are the same subsets. We have red, blue, yellow, blue, and then the set itself. Had this been list the proper subsets, this last set that I'm writing would not exist. Because again, the proper subset would include all sets except for the set itself. When we're dealing with Venn diagrams, we're going to have what's called the universal set. And this universal set is symbolized by the letter U. It discusses all elements that are possible within the square. Okay, so we have a little U in the corner. A little bit of trivia. If you ever win the $1 million, I claim 10% of your winnings. Just kidding. So we're going to be using Venn diagrams, and again here the universal set is represented by a region inside the rectangle. So set A, which again is right in the middle there, right here. Set A is a subset of the universal set because it's part of the whole thing, but it contains elements that are in the universal set. We're going to see if we can move this up a little bit. Alright, so here we have U. So the universal set is going to be the set of elements that is a triangle, square, and the numbers 5, 7, 9. Those are all the elements within the square. The U and the A just indicate sets. So this is a universal set. And A is just describing, again, the set A. Remember that when we describe sets, we have capital letters. So it's just a set, not an element. And then we have set A, which contains 2 shapes, the triangle and square. And then the set of elements not in A, we have the rest 5, 7, and 9. There you go. We did a little bit of this in class. Like mentioned. Drawing pictures, so disjointed. We'll go ahead and use some quick diagrams. Disjointed implies that you have 2 sets that are not connected. Proper subsets would be set A and then pink, so it's almost all the sets except for the set itself. Keep in mind these are all within a little rectangle, the universal. Equal sets. Recall equal sets have the same elements. So I'm going to draw set A, and then set B is going to be hopefully the exact same circle. Oopsies. The exact same circle. Let's see if we can erase that. Yikes, let's just erase it all and make it cute. Again, so we have, again, our universal. For proper subsets, it is set A, and then set B is most of the elements, or most of the subsets, except for the original. Equal sets, again, are sets that are exactly the same, so the pink circle should be right on top of the green, but again, not drawn well. And then some sets are sets with some common elements are just overlapping sets. Alright, here we go. Practicing the universal set should be, so this is set A. We didn't write in set B, so I'll go ahead and put that there. So set B, the regions, this is region 1, region 2, and region 3. So we are not actually, it should be a region 4. We're not actually going to use those values when we're answering these questions. The universal set are the letters A, B, C, D, E. Set B contains the elements. So A, B, C, D, E. B contains the elements D and E, because we have to take into account the overlapping. So the set of elements in A, but not in B. So that would just be A, B, and C. Because D is in fact in B, so we want to exclude that. Excuse me. The set of elements in U that are not in B. So again, that would be the set A, B, C. And the set of elements in both A and B, and that's just D. When we talk about the complement, we're talking about elements that are not in the circle or set A. And we denote it by this wonderful prime value. A prime gives us our complement. So if the set A were the numbers 1, 2, 3, and then we have to define U as 1, 2, 3, 4, 5, then A complement would be, oops, that's an ugly complement. A complement, oops, would be 4 and 5. The list of numbers that were not in A. So A complement not in A. Okay, so you get a chance to practice. You're given the elements 1 through 9. Set A is 1, 3, 4, 7. Looks like we have quite a bit of, so A complement equals set 2, 5, 6, 8, and 9. Alright, A complement for the second, B, C, and E. Hopefully you understand again, it's the elements that are not in the given set. Intersection is like the word and or but. So it needs to be in the set A and B. So when you're thinking of those elements, think about where those overlap. So that would be in this little shaded region here. So A and B. A and B. Okay, so they're elements in A and elements in B, so whatever they have in common. So in here we have our example. Looks like 8 for sure is common. 10, and that's it. So A and B, or A intersect. Intersect is another way of saying that. Here we have the empty set because there's nothing common about them. And same again. The intersect between any set and the empty set is the empty set itself. Union. Union implies or, so things are going to be one or the other. So we have the word or. Elements in A or elements in B. When I think of union, we think of a marriage. We're taking everything and putting them into one group. So everything in A and everything in B become one big set together. A union B. So here we're going to take all the elements, even the common elements, and put them into one set. So we have 6 is the lowest value, 7, 8, 9, 10, 11, 12. Here we have 1, 2, 3, 4, 5, 6, 7, 8. Nice. And this one we have 1, 3, 5, 7 because it's the set union, the empty set. So there's no elements in the empty set, therefore giving us 1, 3, 5, and 7. Okay, you're going to begin to see operations where it's like A union B or B intersect A union B complement. So just sort of keep that in mind. Here's an example. We're given A union B. We have to do what's in parentheses first. So A union B becomes the sets put together, 1, 3, 7, 8, 9, 10. Then we have to consider this complement right here, thus giving us 2. So whatever numbers are not in green but are in the universal. 2, 4, 5, 6, 7, 8, 9, 10. Complement and complement, so we're talking about sets. That would be 2, 4, 5, 6, 8, 9, not 9, but 10. And then B complement, which I'll do in pink, are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So in looking at the blue and pink set here, our final answer will be the intersect. So what do they have in common? They have a 2 in common. They have a 5 in common. Yep. They should also have a 4 in common, so I need to write that in there. 4. And do they have a 6 in common? Yep. Not 8, not 9, not 10. So our answer is going to be 2, 4, 5, and 6.